Hey everyone, so welcome to this video, and in this video we'll solve one of the most important problem on graph data structure. Okay, so the problem statement is we just need to input any graph, right, and find out whether the graph contains cycle or not. So let's say this is graph number 1 and this is graph number 2. Okay, so here in the first graph you can see that there is a cycle. So here we have 0 1 2 3 4 and again 0. So this is a cycle. Okay, but in the second graph there is no cycle. So here in this case we have 3 4 0 1 and 2, and there is no edge between 2 and 3. So there is no cycle in this graph. So in the first case we just need to return yes, the graph contains cycle. Okay, and in the second case we need to return no, that this graph doesn't contain cycle. So this is the problem statement, right? Okay, so in this video I'll show you how you can solve this problem using DFS, and in the later video we'll see the code of this algorithm. Okay, so let me rub this. Alright, so what we'll do, we will pass this node, that is root node number 0, to the DFS function. So let's say this is DFS function. Okay, so the first step that we do in DFS function is to mark the node as visited. So let's say this is a visited matrix, so we'll mark the root node as visited. Okay, so this is step number 1. We'll mark the root node as visited. Now the step number 2 is to explore this node. So 0 is connected with 1 and 4, and both these nodes are unvisited. Okay, so we have two options here. We can go to any of these nodes. So let's go to node number 4, right? Now for node number 4, the first thing that we'll do, we mark this node as visited. Okay, and the second thing is to explore this node. So node 4 is connected with 0 and 3, right? But 0 is already visited, and 0 is the parent of 4 because we are coming to 4 from 0. Okay, so 0 is the parent of 4, right? This is very important. 0 is parent of 4. So we have only one option, that is 3. So we'll go to node number 3 because it is unvisited, and we mark this node as visited. Okay, and explore this node. So here in this case 3 is connected with 4 and 2, and if I talk about 4, so 4 is already visited and 4 is the parent of 3, right? Because we are coming to 3 via 4, so 4 is the parent of 3. But in case of 2 it is unvisited, so we'll go to node number 2, right, and mark this node as visited and explore this node. So 2 is connected with 1 and 3, but 3 is already visited. Okay, and 3 is the parent of 2 because we are coming to 2 via 3, so 3 is the parent of 2. So we have only one option, that is 1. So we'll go to node number 1, and again we'll mark this node as visited. Okay, and the second step is to explore that node, right? So node 1 is connected with 2 and 0, right? So 2 is already visited and 2 is the parent of 1 because we are coming to node 1 via 2. So 2 is the parent of 1, right? But if I talk about 0, 0 is already visited, right? And 0 is connected with 1, but 0 is not the parent of 1, right? So here we have two cases. 0 is already visited, and the second one is 0 is not the parent of 1. 0 is not the parent of 1. Okay, so in that case it means that there is some kind of edge between 0 and 1 because we can go to 0 via 1. Okay, but 0 is not the parent of 1, so this there contains a cycle in this graph. Okay, so this is the idea, right? So if these two conditions satisfied, the first one is if the node is visited and if that node is not the parent of the current node. Okay, if both these conditions are satisfied, then it means that the graph contains cycle, right? Now let's talk about this graph. Okay, So what we'll do, we'll pass root number 2, that is this node, to the DFS function, okay, and mark this node as visited, right? Now the second step is to explore this node. So 2 is connected with 1 and 1 is unvisited, okay. So we'll go to node number 1, correct, and mark this node as visited and explore this node. So 1 is connected with 0 and 2, and 2 is already visited, and 2 is the parent of 1 because we are coming to 1 via 2. So 2 is the parent of 1, but 0 is unvisited, so we'll go to node number 0 and mark this node as visited and explore this node. So 0 is connected with 1 and 4, right, but 1 is already visited and 1 is the parent of 0, okay. So because we are coming to 0 from 1, so 1 is the parent of 0, so we have only one option, that is node number 4. So we'll go to node number 4, okay, and mark this node as visited, right, and explore this node. So node 4 is connected with 0 and 3, but 0 is already visited, okay, and 0 is the parent of 4, right. So we have only one option here, so we'll go to node number 3 and mark this node as visited and explore this node. So 3 is connected with only 4 and that is already visited, right. So there is no other option, so it will return back to its parent node, okay. Now for 4 there is no other option, so it will return back to 0, and again for 0 there is no other option, it will return back to 1, and similarly 1 will return back to 2, and 2 will return back to the main function from where it is called. So you can see that these two conditions are not satisfied. It means that the first one is the node is visited, and the second one is the node is the parent of the current node, okay. So in this case there is no cycle because these two conditions are not satisfied for any of these nodes here, okay. So this is how we find whether the graph contains cycle or not, right. So in the later video we'll discuss the code of this algorithm, okay. So thank you.